Yes. Now I am relative sir. So we wanted to attend. He died 6 months back. He marriage LWP part ಬಂದಿದ್ದೀನಿ ಸರಿ ಮೇಡಮ್ ಜೋಡಿ ಮಾತಾಡ್ತೀನಿ
ಪ್ರಿನ್ಸಿಪಲ್ ಸರ್
so for here madam ಯಾಕಂದ್ರೆ when I was studying in Hubli I stayed in their house
Okay. So good morning everybody. So coming back to the block diagram reduction rules which I was discussing yesterday. Are you able to see the screen? All of you? Are you able to see the screen?
Yes ma'am.
Okay. So in yesterday's class, I discussed 3 rules. The first rule was the associative law, where you can interchange the summing points which are side by side, and also they don't have in between them any block or any other summing point or takeoff point. In that case, without affecting the output of the block diagram, you can interchange the summing point. That is what the associative law says. Then the second rule that we studied was blocks in series. When the blocks are connected in series, that is continuously connected without any takeoff point or a summing point in between them, then the blocks can be said as series blocks, and those blocks G1, G2, G3 or whatever, they can be multiplied, and the transfer function of them will be the multiplication of individual transfer functions. That is rule number 2. Then rule number 3 was blocks in parallel. So when the blocks are connected in parallel, that is they have the same input and they end at a same summing point. All the blocks, the signal from all the blocks ends at the same summing point. Such blocks are called as parallel blocks. That is, for these blocks, the starting point is same and the ending point is same, and in between there are no takeoff points or no blocks. Then those are called as parallel blocks, and the effective transfer function, that is the summing transfer function, will be sum of individual transfer functions of these blocks. So that is what we studied in yesterday's class. I think somebody is trying to join. I will just check, and then somebody is joining. Okay, let me admit, and then okay. So now I will come back to rule number 4. Okay, rule number 4, that is shifting of a summing point behind a block. The rule number 4 says shifting of summing point behind a block. Okay, so what happens is when the blocks are in series or parallel, what is the rule is there should not be any summing point or takeoff point between the series blocks. If there are any summing points or takeoff points, we can't go ahead with the problem to apply the series block or parallel block rule. So in that case, rule number 4 says you can shift a summing point behind a block. Okay, so now consider figure number 5.19. Okay, look at figure number 5.19. In this, there is an input R to a block G with transfer function G. From block G, there is a summing point, and from there an output C of S goes. And to this summing point, apart from the signal coming from G, one more signal in the form of plus Y also enters. That means here the output is RG. This is RG, this is plus Y. So the output is RG plus Y. Okay, this is the situation. This is the situation. Now I want to shift the summing point from this point to behind the block. Okay, this point to behind the block as shown in figure 5.20. But I want the output to remain as RG plus Y only. I don't want change in output. So that situation is represented in figure 5.20. That is, from this side of the block, the summing point is shifted this side. Okay, let it be shifted as it is. With instead of Y, let the signal be X. Then let us see what is X. So see here, in this case, the output is what? This is R, this is X, R plus X, R plus X into G is the output. R plus X into G is C of S. But we want this to be equal to RG plus Y. That is, RG plus XG should be equal to RG plus Y. That's why XG is Y or X is equal to Y by G. That means to this Y, you have to multiply with 1 by G. That means, see here, this is the changed figure. This is the changed figure. Suppose you want to shift a summing point behind a block, then along with the signal, whatever was there, that is Y was the signal. What was the initial signal? Initial signal was Y. So to that Y, you have to add a block. Add means multiply or put in line one more block, that is 1 by G, so that the effect will be Y by G. So now if you put Y by G here, then what is there after the summing point? R plus Y by G. R plus Y by G into G. So R plus Y by G into G is equal to R G plus Y. Okay, that is C of S, which is similar to this. So the output is not changing. The output is not changing. So the rule number 4 says, whenever you want to shift a summing point behind a block without affecting the output, if you want to shift a summing point behind a block, then multiply the signal, whatever is going to summing point, with a block 1 by G. That is 1 divided by behind whatever block you are shifting. This what I would like to do is again explain you with the help of a blank screen. Okay, just like I did yesterday, I would like to explain it to you with the help of a blank screen. Okay. Wait for a minute. Okay, so now we have a blank screen. The same situation, whatever I had shown, I will just show it to you. The same situation, what I explained right now. So there is one block here, G. To this, there is the input R. After this, there is this summing point. And after this, there is C, R of S, you can say, or R only, you can say. To this summing point, one more signal plus Y is going. So here, this is R, this is G. G is the transfer function of the block. What is the signal here? RG. Okay. Of course, if it is not, if the sign is not there, then we have to assume it positive. So R at this summing point, one signal is RG, another signal is Y. So what will be the output? Output will be RG plus Y. Output will be RG plus Y. Now, I want to shift this summing point from this position to behind G. I want to shift it behind G. So now, if you shift it behind G, what will happen? Let us see. So if you shift it behind G, G will be here. Then this summing point will come here. Then R will be as it is. And instead of Y, because you have shifted, let us say it is X. What is value of X? We will see later. then this will be what? C of S. I want it to be C of S. So now if this is flux, what is this signal? R plus X. This signal is R plus X. Then what will be C of S? R plus X into G. R plus X into G. While as here it is RG plus Y, here it is R plus X into G. I want both of these to be equal. So I write RG plus Y must be equal to RG plus plus GX or XG. RG plus XG. So now RG gets cancelled. Y will be equal to X into G. Y will be equal to RG plus Y. RG plus Y must be equal to RG plus XG. RG plus XG. So X is what? Y divided by X is nothing but Y divided by G. X is Y divided by G. That means Y into 1 by G. 1 by G. So how you represent it in the form of a picture? How do you represent it in the form of picture? So if now you have to draw a block diagram. So now this is G. This is the summing point. This is R. This is C of S. Okay, this is C of S. So this is our X. X is, so Y is already there. And here you have to put one more block, which is 1 by G. So that this will be what? Y by G. So now what is the signal here? R plus Y by G. R plus Y by G into G is C of S into C. So that is RG plus Y. That is C of S. So whenever you have to shift a summing point behind the block, you have to add in series with it the block in reverse beyond which you are shifting. Is that clear to you? Is that clear to you? That is how it is done. Okay, that is how it is done. So now let me go to the next rule, that is rule number 5. Okay, let me move to what? Rule number 5. What does rule number 5 says? Let me see. Okay. So now coming to rule number 5. This is rule number 5. In rule number 5, what we have done in the previous rule, we have shifted the summing point behind the block. Now we will shift the summing point beyond the block. Beyond andra adra munda. In front of the block. Agal en madidvi? Hinda. Iga in front of the block. So now this is the existing situation. Here the summing point is here. And the signal that is going to summing point is plus Y. This is R plus Y. This signal is R plus Y. That is going to G. So C is equal to R plus Y into G. Existing situation. Now I want to get this summing point this side. I want to shift this summing point in front of G. Adar mundu tagond barbekagide. Now to shift the Afrad, shift the summing point after the block, keeping the output same. Consider the shift summing point without any change. I want to shift, but I want the output to be same. What is the output? What is the output? The output is C equal to RG plus YG. So this output should remain the same for me, but I want the summing point after it. Okay. So for that, what I should do? So again, let me consider this as X. So if you consider this as X, this will be RG plus X. RG plus X should be equal to RG plus YG. So X is YG. X is YG. X is YG. As you can see here, X is YG. Okay, X is YG. That means when you shift a summing point after a block, you have to multiply the signal that is entering the summing point with the same block beyond which you are shifting. Same block beyond which you are shifting. Agar en madidvi 1 by that block. 1 divided by G you had added in series. Now you have to add the same block beyond which you have shifted. The same block. That means G only you have to add. So that is shown in this figure 5.24. That is shown in this figure 5.24. As you can see here, you can see that. Now again the output is RG plus YG. You can see the output is RG plus YG. The signal Y must get multiplied with the transfer function of the block beyond which the summing point is to be shifted. So that is, see, if you have understood rule number 4, rule number 5 is also same. Only thing is in rule number 4, you are shifting the summing point towards left. Here you are shifting the summing point towards right, but you are jumping the block. Okay, you are jumping the block. In both the rules, you are jumping the block. Okay, so let me move to rule number 6. Okay, rule number 6. So what does rule number 6 says? Shifting a takeoff point behind the block. Okay, shifting the takeoff point behind the block. Again, we had done for a summing point. Now we are doing it for a takeoff point. So consider the situation. So this is the situation. There is this input to this block G. After block G, a takeoff point is going with a signal Y, and Y is equal to RG. Y is equal to RG, and this is the output. And this is the output. Somebody has joined. Let me admit and then present again. Okay. So here, this is the situation. This is the takeoff point, and this is C. So C is also RG, and the takeoff Y is also RG. So I want to get this takeoff point behind this. See here, I have got it behind. Idanna himbarki tagond barbeku. Himbarki tagond barbeku, and the output should remain RG only. Okay, the output should remain RG only. So what I should do for that? So to shift the takeoff point, behind the block, the value of the signal takeoff must remain the same. Okay. So if that has to be done, then it must be equal to RG. So a block with transfer function must get introduced in the block. So for that, what I have to do is I have to we have to introduce transfer function. G must be introduced in series with the signal taking off after the block, so that nothing gets affected, so that we don't want anything to get affected. So what I will do is I will introduce a signal Y equal to RG in the block. Okay, so that I will explain in the blank screen. Let me explain in the blank screen how that takes place. So let me consider the situation here. So there is one block G. There is one block G, and the input to this block is RG. So from here, what comes? RG only, isn't it? R into G. So that is being taken off here, Y equal to RG, and here C also equal to RG. C also equal to RG. But now I want to get this takeoff point behind like this. I want to takeoff point. But from here also I want the signal to be YG only. I want the signal to be YG only. So what I will do? So this is G, this is R. Here I have taken off Y. Here I have taken off Y. Here it is RG. This is C equal to RG. So now this is, say, let me say this is X. So what is X in this case? What is X in this case? X is R. X is R. But what is the signal going here? RG. Okay. Signal going here is RG. So if you want to make this RG, what I have to do? I have to introduce G here. I have to introduce G. So now this Y is equal to R into G. Y is equal to R into G. Okay. So to shift a takeoff point behind the block, in the signal which is taking off, you have to add in series the block behind which you are shifting. Okay. You have to add in series so that this remains. See here, output is not going to get affected, but the signal taking off is going to get affected. So to that, you have to add a block in series. That is what is rule number 6. Okay. So now coming to the next rule, that is rule number 7. Okay. Let me come to the rule number 7. Okay. So what does rule number 7 says? See here, shifting of takeoff point beyond the block. Agale ಏನು ಮಾಡಿದ್ವಿ? ಹಿಂದೆ ತಗೊಂಡಿದ್ವಿ. ಈಗ ಏನದಲ್ಲ ಮುಂದೆ ತಗೋತೀವಿ. ನೋಡಿ. So this is the situation. The takeoff point is behind the block. I want to shift it this side. So in that case, add a block with 1 by G. Add a block with 1 by G. Okay. So to shift a takeoff point beyond the block, the value of Y must remain the same. To keep the value of Y constant, it must be multiplied by 1 by G. Okay. So now 2 rules 6 and 7 are same. In 6, you are shifting the takeoff point behind the block. In 7, you are shifting the takeoff point beyond the block. Rule number 4 and 5 are also same, in which you are shifting the summing point behind the block and summing point beyond the block. Okay, 4 rule almost one day. Adrolaga first rule, under rule number 4 olaga, when you are shifting a summing point behind a block, you are adding 1 by G. When you are shifting beyond, you G. Takeoff point behind bandaga G, beyond bandaga 1 by G. That is the difference. So all these rules you have to go through and study. Okay, go through and study. So coming to rule number 8, very easy and very interesting rule, removing of minor feedback loop. This is rule number 8. So in rule number 8, what it says is, whenever the block diagram has come to this form, which is called as, this is loop form or canonical form. That is, there is one summing point, one block in forward path, one takeoff point, one block in feedback path, one input, one output. This is called as a feedback loop. Then you can eliminate that feedback loop using the formula G of S divided by 1 plus minus GSHS. This is called as elimination. And idan tagadu bare one block madbidodu. Okay. This is called as removing of minor feedback loop. That is rule number 8. Now coming to rule number 9. For multiple input, multiple output system, that is when there are many inputs and the system has many inputs, then how to obtain the output is consider only one input at a time, treating all other as 0. So for example, here you have R1, R2, R3 dash dash Rn. And to get the output, what you have to do? Consider R1, neglect all other inputs. So the output will be C1. Consider R2, get C2. Similarly, consider Rn, get Cn, and C will be equal to C1 plus C2 plus C3 plus C4 dash 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 Cn. This is called as principle of superposition, which I have already told in the beginning class also. So this principle of superposition you can apply for multi-input systems. When there are multi-input systems, you can use rule number 9. Okay. So you have rule number 1 to 9, which you have studied. Okay. Then coming to rule number 10. Rule number 10 is called as critical rule. Rule number 10 and 11 are called as critical rules which are also very important. In rule number 10 and 11, you are shifting takeoff point after a summing point. Okay, in rule number 10, you are shifting takeoff point after a summing point. Andre idrolaga summing point takeoff point baju baju irtav. Okay, baju baju irtav. Takeoff point after summing point you hakbodu. So consider the situation shown in 5.32. Consider the situation shown in 5.32. Here I want to shift the takeoff point which is located here after a summing point. So now let us analyze. There is this input R1. The same input is being taken off. So X is equal to R1. Then the same thing goes to this summing point at which one more signal Y gets added. And what will be the output here? R1 plus or minus Y. If it is plus, plus or Y. So this is the situation. Now, this takeoff point, I have to get this side without affecting the takeoff signal and as well as the output. I want to do it. Now, after shifting the takeoff point, what will be the signal here? R1 plus or minus Y. So Z is R1 plus or minus Y. But I want it to be R1. I want it to be R1. So what I will do is, if I want to make it R1, here minus or plus Y I have to add. Minus or plus Y if I add, then it will become R1. So how I will do that? Minus or plus ಮಾಡ್ಬೇಕಂದ್ರ this, when plus or minus comes, a summing point comes. So when I want to shift this takeoff point this side, I will introduce one more summing point, and to that I will add this reverse signal. I will add the signal like this. So Y is going here plus or minus. So I will add it so that X becomes R1. So that X becomes R1. R1 plus or minus. This is minus plus. Minus plus. So this what I will do. I will explain it to you on the blank screen so that you will understand. Let me explain it on the blank screen. Okay, blank screen ಮೇಲೆ explain ಮಾಡ್ತೀನಿ ನೋಡ್ರಿ. Stop sharing it. Okay, so see here, let me take the situation like this. There is one summing point. There is one summing point. So there is this input R1. Input R1. So from here, one signal is going. One signal is going. Let me call that as Y. And this is what? So this is C. Okay. So if this is R1, here also you have R1 and Y is also equal to R1. Y is also equal to R1. Y is also equal to R1. So this is plus or minus Y. So what is C? C is it is R1 only. C is R1 only. Now I want this takeoff point to get shifted this side. Okay, get shifted this side, and this takeoff also I want R1 only. So let me do that. So there is this summing point. There is this R1. There is this takeoff point. Let me call that as equal to Z. This is, so here I have R1. Here I have R1. So 1 second. Plus or minus. plus or minus 1. Z. So here, what is there? Plus or minus 1. This is the situation. When I have shifted, what is Z equal to? Z is equal to, see here, this is R1, while as Z is what? R1 plus or minus Y. R1 plus or minus Y. Z is R1 plus or minus Y, but I have to make it as R1 only. I have to make it as R1. If I have to make it as R1, here I have to add minus plus Y. If I add R1 plus or minus Y, minus plus Y, then this and this get cancelled, it will remain R1. So, but how I have to put it in the form of a diagram? How I can put it in the form of a diagram? See the third figure. This only I am converting like this now. So this is R1. This is R1. So this is plus or minus Y. Plus or minus Y. So here what I will do is, this plus or minus Y, I will put this side as minus plus Y. Minus plus Y. And this is as it is. This is as it is. This is C. This is the summing point. So now this is what? R plus or minus Y. R plus or minus Y. Then what will be this signal? R plus or minus Y. Then minus plus Y, that is equal to R1. R1. So we got the same signal. So when you have to shift a takeoff point beyond a summing point like this, you have to add one more new summing point to that takeoff point with the signal which is reverse in sign of the signal that is going to the previous summing point. To the previous summing point, the signal going was plus or minus Y. And to this new summing point, the signal going is minus or plus Y. So that the signal taking off remains R1. Is it clear? This is called as critical rule number 10. This is a critical rule and it is rule number 10. So now coming back to the next rule, that is also a critical rule and it is rule number 11. It is rule number 11. Okay, one second. Wait for a second. I will come back. I am opening the PPT. One second. Wait for a moment. One second. There is connection problem. It is hanging. Wait for a moment. Chrome is not responding.
ಮೇಡಮ್ ಸೌಂಡ್ ಕೇಳಲಾಗೈತ್ರಿ ಮೇಡಮ್.
Now you are able to hear?
ಎಸ್ ಮೇಡಮ್ ಈಗ ಕೇಳತ್ತ.
ಭಾಳ ಹೊತ್ತಾಯ್ತಾ ಬಂದಾಗಿ?
ಅವ್ರಿ ಮೇಡಮ್ ಒಂದು 5 ಮಿನಿಟ್ ಆಯ್ತ್ರಿ ಮೇಡಮ್.
ಮತ್ತೆ ಹೇಳ್ಬೇಕಿಲ್ಲಪ್ಪ, ಮತ್ತೆ ಸುಮ್ನೆ ಕೂತ್ರೆ ಹೆಂಗ? ಅದೇನೋ ಕೈ ತಟ್ಟಿ ಆಗಿರ್ತದ. ಮತ್ತೆ so I will take up the problems in the next class because most of you have left. Only 2 are remaining. ಇಬ್ರೇ ಉಳಿದಿರಿ. ಯಾಕದು ನಡು ಹಂಗ್ ಕ್ಲಾಸ್ ಬಿಟ್ಬಿಟ್ರ? Okay, I'll continue in the next class. Okay.